With the help of our mathematical knowledge, let us find expression for improper axis of rotation and operation based on that. That's a rotoreflection operation. Because matrices we are representing for action. Symmetry element and symmetry operations are related to each other. So I represent general Sn is equal to Cn. Let us consider Z as a rotatory axis. If Z is a rotatory axis, then the plane through which we will do the reflection in case of the rotoreflection operation will be perpendicular to that axis. That's xy plane. So I consider the sigma xy. I know the matrix for Cnz. I know the matrix for sigma xy. Cnz means rotation by theta degree I am considering. What is the matrix for that? Cos theta minus sin theta 0, sin theta cos theta 0, 0, 0, 1. And what is the matrix for sigma xy plane? It is 1 0 0 0 1 0 0 0 minus 1. Do the multiplication. We will get the matrix for Sn. It is a general representation. See the answer. Let us work to find the result. First matrix is a matrix for rotation operation. Cos theta minus sin theta 0, sin theta cos theta 0, 0, 0, 1. And second one is a reflection through a plane xy. Remember, the plane is perpendicular to the principal axis. In xy, who is not there? Z. So Z component will be minus 1 and other will be 1 1. So resultant matrix for sigma xy is 1 0 0 0 1 0 0 0 minus 1. Now important is multiplication. What I will choose? I will choose first row of the first matrix and will multiply with first column of the second matrix. So multiplication is shown there. 1 into cos theta plus 0 into minus sin theta plus 0 into 0. That's one of the element of resultant matrix. Now, how to generate the second element, second term, second portion of the first row? Take first row and second column of the second matrix. So multiplication will be 0 into cos theta plus 1 into minus sin theta plus 0 into 0. Now how to generate third element from the first row? Take first row of the first matrix and third column of the second matrix. Multiplication will be 0 into cos theta plus 0 into minus sin theta plus minus 1 into 0. Now let us obtain the multiplication for second row of the first matrix and various columns of the second matrix. What is the second row of the first matrix? Sin theta cos theta 0. I'll multiply with the various columns. So second row and first column of the second matrix. 1 into sin theta, 0 into cos theta plus 0 into 0. Now second row and second column of the second matrix. 0 into sin theta plus 1 into cos theta plus 0 into 0. Now last element of the second row. Second row of the first matrix and last column of the second matrix. 0 into sin theta plus 0 into cos theta plus minus 1 into 0. Let us obtain now results of last row. Last row of the first matrix and various columns of the second matrix. Now one by one. Last row of the first matrix and first column of the second matrix. 1 into 0 plus 0 into 0 plus 0 into 1. Last row of the first matrix and second row of the second matrix. 0 into 0 plus 1 into 0 plus 0 into 1. Now last portion. Last row and last column. 0 into 0 plus 0 into 0 plus minus 1 into 1. Now you will understand the summation of those. What's the summation of the first element? That's a cos theta. Next minus sin theta. Next 0. Now in second row sin theta, cos theta and 0. And in third row 0, 0, minus 1. Yes, that's a matrix for improper rotation. Rotation reflection operation. Rotation by angle theta. So if I consider Z as a rotatory axis, then matrix can be cos theta minus sin theta 0, sin theta cos theta 0, 0, 0, minus 1. Important point now is its character. Character is a summation of diagonal elements. So which are the diagonal elements? Cos theta and minus 1. So what is the summation? 2 cos theta minus 1. It's an understanding about the derivation of improper axis of rotation or rotation reflection operation by rotation of angle theta. Are you following? Let us obtain the matrix for rotoreflection operation. rotation around x-axis. Therefore, S and x is equal to C and x into sigma yz, because if we are considering rotatory axis as the x-axis, then the plane perpendicular to the x-axis will be yz only. Therefore, sigma yz is considered. We were knowing rotation matrix for rotation by angle theta around z-axis. What was that matrix? Cos theta minus sin theta 0, sin theta cos theta 0, 0, 0, 1. Means 1 was there for z component, 1 was there for A33 component, 1 was there for the element which is in third row and third column. Now our rotatory axis is x-axis. So 1 will be where? 1 will be where for x component. Which is that x component? That x component will be in first column and first row. So first element will be 1. Except that first row and first column, remaining 4 elements will be with our sequence. What is our sequence? Of trigonometric functions cos theta minus sin theta, cos theta. Therefore, matrix for C and X will be 1, 0, 0, 0 cos theta minus sin theta, 0 sin theta cos theta. What about the reflection operation through yz plane? In that yz letters, who is not there? X is not there. So x coordinate will completely reflect, x coordinate will completely change. So we use the -1 term for that. So for x, there will be -1. So what I want to say, A11 will be -1. Remaining things will be what? 1 along the diagonal. So matrix will be -1, 0, 0, 0, 1, 0, 0, 0, 1. Now important thing is multiplication. During multiplication, what we will do? We will choose first row of the first matrix. Then stepwise we will consider the columns. First time first column, then second column, then third column from the second matrix. And multiplication of respective numbers, and directly we will write the answer there. Here only by observation we should able to grasp the multiplication and summation. Where numbers are coming, that answer we need to write. If 0 is there and multiplying to anyone, answer certainly will be the 0. That's a simple basic. Let us start now. First row, that's a 1, 0, 0. And first column, -1, 0, 0. Here 1 and -1 can give the fruitful result. Answer is -1. Otherwise, answer is 0. Now to generate the second element of the first row of the resultant matrix, first row and second column I have to consider. Respective numbers when they come, then we will find 0 is there everywhere. So answer is 0. To generate the third element in the first row, consider first row the first matrix and third column of the second matrix and match those numbers. What we are finding? 0 is there in everywhere. So answer is 0. Now let us generate first element of the second row in the resultant matrix. Consider second row of the first matrix and first column of the second matrix and combine respective numbers. What you are finding? 0 is there everywhere. So answer is 0. Now let us generate second element of the second row. Consider second row and second column. So when you will combine, you will find one where, yes, 1 into cos theta you will find. So answer is cos theta. Otherwise 0 is there. So result is cos theta. Let us generate now third element in the second row. 0 cos theta minus sin theta is our second row. And third column now 0, 0, 1. When they will combine, who will combine? 1 into minus sin theta. Answer is minus sin theta. So minus sin theta is represented as a third element of the second row in the resultant matrix. Likewise, third row and first column of the second matrix. Who will combine to give the significant result? Nobody, because everywhere 0 is there. So answer is 0. Third row and second column. Who will combine? Yes, 1 and sin theta. Answer is sin theta. Now, third row and third column. Who will combine? Yes, 1 and cos theta will combine and answer is cos theta. So resultant matrix is now -1, 0, 0, 0 cos theta minus sin theta, 0 sin theta cos theta. This is a matrix for rotoreflection operation where rotation is around x-axis. What is its character? Character is a summation of diagonal elements. Which elements are there along diagonal? -1 cos theta, cos theta. So answer is 2 cos theta minus 1. Same character was there for the improper rotation axis or for rotoreflection operation where rotation was considered around z axis. So character has not changed. Character remains same, but matrix representation had changed there. Once this derivation is clear, similar pattern you can follow and you can obtain or derive rotoreflection operation, where rotation we can do around y-axis. If you carefully read the resultant matrix, you will find only -1 is there at the first place. Otherwise, complete matrix of rotation is there, and rotation sequence is cos theta minus sin theta, cos theta. It means if z is there, then only at z -1 will be there. I consider the rotation around y-axis, then what will be there? At y component, at central place -1, otherwise the same sequence of the rotation will be there. Let us find the matrix directly for rotoreflection operation where rotation is around y-axis. How can we represent the expression to find the rotoreflection operation where rotation is around the y-axis? There C and Y means rotation operation around y-axis followed by reflection through a plane perpendicular to the y-axis. Which plane is perpendicular to y-axis? Yes, xz plane. Therefore, sigma xz is represented. What's our general representation for the rotation operation for rotation around the y-axis? Cos theta 0 minus sin theta 0 1 0 sin theta 0 cos theta. It is rotation. And for reflection, where y component will be the -1, 1 0 0 0 minus 1 0 0 0 1. After multiplication, you will find 1 becomes -1. Rest of the things remains as it is. Likewise, you can represent directly the matrix for rotoreflection operation where rotation is around y-axis, and that matrix is cos theta 0 minus sin theta 0 minus 1 0 sin theta 0 cos theta. What is its character? 2 cos theta minus 1. Same character was there for rotoreflection operation around z-axis, around x-axis. So characters are same. Now one interesting thing I inform to you. As like in the rotation operation, we were just substituting value of theta and we were finding the matrix for that. But here, improper rotation we are talking about, in which rotation followed by reflection is there. Whatever the matrices we obtain, it is for SN1. That's the first operation on improper axis of rotation. In case if I continue my operations, means SN2 if I consider, then sigma square will be identity and it will result as like the rotation operation. But what about that -1? -1 will not undergo any change because we have considered as it is in the improper rotation axis operation. Therefore, what I wanted to say, whatever these results are there, those are applicable where rotation and reflection combo operation, unique operations are there for unique results of improper axis of rotation. We have to follow this matrix. Do not follow it for general, and it is the reason why we do consider in case of S3 is improper axis of rotation, S31 and S35 where sigma is odd. We do not consider other operations. We consider those operations where characters are same. If I consider S4 as improper axis of rotation, we do consider S41 and S43, means we don't consider S42. The reason you will find in the matrices. What is our important point? Character for those operations should be same. Then only we can bring them in one class. And when we consider class for improper axis of rotation, those only operations we are considering where characters are same. I hope you are getting this point. Little bit difficult to digest. If you revise this audio, you will understand the concept clearly. Now, as a homework, I have one question to you. Find character for rotoreflection operation where rotation is by 60 degree. I want to ask, find character for S6 operation. Let's say you consider S61 operation.